Good evening, everyone. Yesterday we have studied the basic concept of solid state physics, free electron theory, and semiconductor as well as superconductivity. First, we started in earlier lesson or earlier session basic theory of free electron, who discovered the free electrons, and classical theory of free electron and success of the free electron theory. Today we will discuss about the session 2. The topic is free electron theory in the basis of solid state physics, expression for the electrical conductivity of free electron theory of metals. So we have discussed about, first of all, free electron theory, the various properties of metal such as electrical and thermal conductivity. So you have to know already the success of the free electron is also came to the electrical conductivity and thermal conductivity. So in the other cases, the thermoelectricity and thermoionic and photoelectric effect, etc., can be explained on the basis of free electron theory. Thermoelectricity also used the free electron theory, that is the laws of intermediate metals and laws of thermoelectricity. There is thermoelectricity where some important scientists will be discovered, that is a Seebeck or filter. So different types of the scientists are discuss the thermoelectricity concept to using the laws also, that is the free electron laws. So thermoionic and photoelectric effect on the basis of dual nature of matter waves. So using the thermoionic emissions or photoelectric effect or stopping potential or threshold frequency. So we have to consider on the basis of dual nature of matter to explain the on the basis to free electron theory. So main important, the metal exhibit the following properties are there. The following properties, so many of their, so first of all, the high electrical and thermal conductivity we have to know already. The first one, there is a high electrical and thermal conductivity because the main use the free electron theory, electrical conductivity and thermal conductivity, and it obeys the Ohm's law. Yesterday we have discussed about the success of the free electrons theory, so we have to study the which obeys the Ohm's law, because Ohm's law is I is directly proportional to V. So electrons flows through the negative direction to positive direction, the opposite directions of the electric field. So in the steady state they obeys the Ohm's law, so I is directly proportional to V. And the solid state physics on the concept of the crystal diffractions, they have the some important scientists will discover the crystal structure. So Einstein on the Debye, Einstein theory of specific heat and the Debye theory of specific heat of the temperature. So in the free electron theory, in the cases the Debye temperature is proportional to the absolute temperature. So we have take the rho is directly proportional to T, which means the resistivity of the Debye temperature, it is directly proportional to the absolute temperature, which is on the basis of the free electron theory, which exhibit the properties of the free electron. We consider at low temperature the resistivity of the metal is proportional to the fifth power of absolute temperature. So rho is directly proportional to fifth power of T. and the resistivity is inversely proportional to pressure, so rho is inversely proportional to 1 by P, and absolute temperature or absolute resistivity is 0 and certain metal tends to 0 or the conductivity tends to infinity. So we have to, these conditions will exhibit the following properties of free electron theory of metals. So next we have discussed about the expression for the electric conductivity. So we have defined the sigma. How to define the expressions? We have to know the, see the figure. These are the voltage, potential barrier, that is positive and negative, and the electrons which flows to the positive to the negative end. So we have to take the force F is equal to minus E into capital E, because the charge of electron in opposite direction, so we have take the charge of electron is negative. So electric field which oppose the flow of electrons, so we have take the capital E also taken that, and the length of the cylinder we have to take the small l. And how it works on the cases, we have to see that. First one, let a potential difference V be applied to the metal rod of length L. You have to see that. First one, the potential difference is applied and length of the metal rod L of unit area cross section, then the force each is electron in minus E into E. We have know that, where capital E is the electric field. So we have take the expression, hence M is equal to, hence m d square x divided by dt square is equal to minus E into E. We have to take the equations, the F is equal to the force applied to the conductor, then F is equal to m into A. So F is equal to m is a mass, A is a acceleration. So accelerations we have taken as the d square x divided by dt square. So we have take the equations, m a, F is equal to force minus E into E, where m we have to take, consider m into A is the acceleration, we have to take the A is a d square x divided by dt square, and next in d square x by dt square is equal to minus E divided by m into E, and this m is going to the this section. So d square x divided by dt square is equal to minus E divided by m into E. Then equation will be integrated. So integrating of the d square x divided by dt square is equal to minus of integration E divided by m into dt with respective t. So integrating the with respective t. So integrating these equations, then we get the finally dx divided by dt is equal to minus E of E m into t plus of c, where c is the integration constant. When the integration constant is 0, the time taken of the conditions and the x of the substitute will become 0. Hence the equation 2 becomes, when the integration constant c is 0, the equation 2 becomes dx divided by dt is equal to minus E of E divided by m into t. This is the equations of accelerations. And the next one, we have to see the figure, the cylinder we have to say that, and the cylinder with the distance of the length of the cylinder we have defined the L. So L, the distance of the two peaks to be getting the total mean pre-path. So if mean pre-path, that is the distance between successive collision, is lambda, then the time interval between successive collision is, we have taken the tau. Tau is equal to lambda divided by u. So we have take the tau is equal to lambda divided by u, where lambda is the wavelength and u is the velocity along the x-axis. the average distance between two mean free path. So we have defined in the cases, so take the two collision, we have the equations will be defined. Dx bar divided by dt is equal to 1 by tau. So we have take the equations, dx bar divided by dt is equal to 1 by tau integrations 0 to tau into dx divided by dt. So we have substitute the dx divided by dt, we have take the minus e capital E divided by m into t into dt. So substitute and integrating the equations, the minus will be taken outside, the minus 1 by tau e into e divided by m, only integrating the small t. So integrating the small t is t square divided by 2, or upper limit and lower limit will be 0 to tau. So minus 1 divided by tau e into capital E divided by m, where small t we have substitute the limits, that is tau square divided by 2. So tau will be get cancel. So dx bar dt is equal to minus of e capital E tau divided by 2m. This is the successive collision between the two wavelength. So we get the dx bar divided by dt is equal to minus of e tau divided by 2m. If the circuit of the electric field or electrical conductivity, in the cases the voltage will be developed, then the cases the current flowing through it. So the current passes through the conductor, the electrons will be shaped aligned, then flows through the positive to negative directions. So we have take the current density. Now if I be the current density and n be the number of electrons per unit volume, so we have take the current I is equal to minus ne dx bar divided by dt using the current electricity. So minus ne, n is a number of electrons per unit volume. So minus ne dx bar dt is a successive collision. So substitute the equation, dx bar dt is equal to minus of ne divided into e tau divided by 2m, then multiplying both, so minus into minus plus ne square capital E tau divided by 2m. So where tau we have already told that is a lambda divided by u. Substitute tau value, ne square e tau means lambda, so ne square capital E lambda divided by 2mu. This is the current density of the electrical conductivity. Then the current density of the electrical conductivity equations to multiplying dividing by the u in one side, that is the right hand side. So I is equal to 1 by 2 ne square e lambda u divided by m into u square. 1 by 2 taken common, so ne square e lambda means lambda, and multiplying dividing u upper side and numerator also u, and m into m mu square. And we get the equations from the kinetic theory of the gases. We have to know that kinetic energy is equal to half mu square. So kinetic energy of the equation half mu square is equal to 3 by 2 kBT according to kinetic theory of the gases. So we have take the equations from the kinetic theory of the gases, half mu square equal to 3 by 2 kBT, where kb is defined as the Boltzmann constant. You have know that. Then the Boltzmann constant value, and substitute the values in the cases the current density. First we have to consider, and 2 will be get cancel, only left mu square into 3 kb into t. Then we get the mu square of the equations to substitute the current density of the electrical conductivity. So I is equal to 1 by 2 ne square e lambda u divided by mu square. Only mu square will be substitute these equations. So equations will getting the I is equal to 1 by 2 ne square E lambda u divided by 3 kBt. Substitute the equations of the mu square. So we getting 3 into 2 6 kBt ne square E lambda u. This is the expression for the current density. But the current density of the electricity is I is equal to sigma E, where sigma E is defined as the electrical conductivity. So we have substitute the electrical conductivity of the equations to the current density. So I is defined in the cases of sigma E, and sigma E is equal to Ne square E lambda u divided by 6 kBt, and sigma will be left, then E will be cancelled. So sigma is equal to Ne square lambda u divided by 6 kBt, and this is expression for the electrical conductivity. This is the main important theorem of the free electron theory. So how to take the expressions? Easily we have to taken the equations for the different types will be came that. How to came that? Easily we have to know that first of all we have to study the how to induct conductivity, prove the electrical properties, and where it is obeys the laws, and how to come the take the equations to verify the electrical conductivity equations. To easily to we have to find out that first we have to take the circuit diagram, the conductors, and the force will be applied and the voltage will be applied of the rod, the length will be L, and force will be applied that. So F is equal to m into A. Then equations will say that m into acceleration d square x divided by dt square, and F equal to ma minus E into E. The equations will be started that. So the equations then started the m d square x divided by dt square minus E into E, and d square x divided by dt square, m is comes to this side, RHS side. So substitute the equation and integrating the equations, then integrating the equations, then finally we getting the second equation, integrating equations, dx by dt is equal to minus of E m divided into C plus C, where C is the integration constant. So substitute the values, and then when get the equations of the acceleration, dx by dt is equal to minus E em into t. So if mean pre path of the distance between successive collision of the lambda wavelength and time interval of the successive collision to define the velocity along the average distance between the collisions, so we have to define the tau. So tau is equal to lambda u, and the equations will taken the average of the acceleration. So dx bar divided by dt is equal to substitute the values of the acceleration's value, then finally get the dx bar dt is equal to minus E tau divided by 2m. Then using the current passing through the circuit, how much current passing through the circuit, then we get the current density equations. I is equal to minus Ne dx bar dt. Then substitute the values and multiplying and dividing by the u, then using the kinetic theory of gases and substitute the current density of the equations, and I is equal to Ne square E lambda u divided by 6 kBt. But the current density of the electrical conductivity, I is equal to sigma E. Sigma E is define the electrical conductivity. So substitute these equations and find out the getting the sigma is equal to Ne square lambda u divided by 6 kBt expression for the electrical conductivity. So we have discussed about the derivations or expression for the electrical conductivity is of the free electron theory. So next class we discuss about the expression for thermal conductivity and Weidmann-French law and failure of free electron theory. Okay.